students, welcome back. Today's topic is Newton's 3 laws of motion. Before studying about the 3 laws, first I will teach you about what is balanced and unbalanced forces, and then we will go into the 3 laws in details. So let's start. First, what is balanced and unbalanced forces? As you can see here, unchanging motion is when body is at rest or is moving with a steady speed in a straight line. Unchanging motion means there is no change in movement. Balanced forces are actually responsible for unchanging motion. As you can see here, there is a tug of war where each team is pulling equally on the rope is an example of balanced forces. The rope will have an acceleration of 0 under the action of this balanced forces. It will therefore remain stationary. What will be the result? Let's see. Where the net force acting is 0 is a balanced force. Here what happens? Here suppose 10 Newton. Suppose here we have applied a force of 10 Newton and this side the force is also 10 Newton. Then what will be the net force? The net force will be plus 10 minus 10 is equal to 0. So it's a balanced force. Similarly, if a body is at rest, completely at rest, then it's also balanced force. If a ball is moving with a constant speed of 5 meters per second, then it's also a balanced force. Then coming to what is unbalanced force. As you can see here, this is a space shuttle. The lift of a space shuttle is an example of unbalanced force. Why? Because there is a change in motion. There is an upward force which is represented by T and a downward force represented by weight. When the upward force is greater than the downward force, then there is an unbalanced force which causes a change in motion. So it's an unbalanced force. Similarly here, let's see. Here suppose 10 Newton and here is 20 Newton. Then the net force is 10 Newton, that is in the direction of blue arrow. Similarly here 20 Newton, here 10 Newton. What will be the net force? It's 10 Newton and the direction is towards the right. Similarly here both are in the same direction. So what will be the net force? It will be 10 plus 20, that is 30 Newton and in the same direction. So this is the case of balanced forces and unbalanced forces. Now coming to this one. Here you can see a house which is at rest. Now in the second picture, the house shakes. So during an earthquake, the house shakes violently. Now let's see this example. Here what happens? In the first case, the house was at rest or stationary. In the second case, we see that the person is moving. When it is stopped by a stone, the person falls down because he has a tendency to move. Similarly, here what happens? The person has a tendency to move and when sudden brake is applied, the person falls forward. These things give us the Newton's first law. What is Newton's first law? A body continues to be in a state of rest or of uniform motion in a straight line unless an external force is applied on it. Here the body is continuously in the state of rest unless a force is applied. When the earthquake was applied, then it shook. Similarly here the body was continuing in the state of motion unless an external force which is by the stone is applied and so body changes. So this was Newton's first law. This law is also called the law of inertia. Now let's see this example. The person is applying force to the wall. The wall may be, let's say the wall has a mass of 50 kg and the person applies 5 Newton with his leg. Now the person applies same 5 Newton to a ball of mass of 1 kg. What happens? The ball moves or accelerates, right? Now this gives us the Newton's second law. what does Newton's second law states? In an easy version, I have written acceleration is produced when force acts on a mass. The mass here is ball, right? Mass of 1 kg. Here the mass is a big wall of 50 kg. So the greater the mass, the one wall here, of the object being accelerated, the greater amount of force is needed to accelerate the object. Here the 5 Newton force was able to move the ball and accelerate it. But 5 Newton force could not even break the wall. So greater mass, greater force is required to accelerate. So this is Newton's second law. Now let's see Newton's second law according to bookish definition. What does it states? The rate of change of momentum of a body is directly proportional to the force applied on it, and this change in momentum takes place in the direction of applied force. Now there are so many words, so let me explain you in an easy way. First, always remember, whenever the word rate is there, it means you have to divide by time. So the rate of change of momentum. What is momentum now? Momentum is the product of mass into velocity. The definition is the rate of change. Rate of change means divided by time. Rate of change of momentum. Momentum here is represented by the symbol P. And what is momentum? It's the product of mass into velocity. Now what is velocity? Velocity is speed in definite direction. So what can be the unit of velocity? It's same as meter per second. Same as speed, but it has a direction. Since it has a direction, it's a vector quantity. We have a separate chapter on vector and scalar that I would be doing in my later videos. As of now, just remember, vector quantities has a specified direction. Suppose you are traveling with a speed of 5 meter per second. But when I say that you are traveling with a speed of 5 meter per second towards north, it's referring to the velocity, because velocity has a direction. So here what? Momentum is a product of mass into velocity, and velocity is a vector, so I will put an arrow over it. Now let's find out what is the unit of momentum. Momentum is mass. Mass is kg. Now velocity is meter per second. So unit of momentum is kg meter per second. So what does this Newton's second law states? Force is directly proportional to the rate of change of momentum. Now from this definition, we will define how that force is equal to mass and acceleration comes. So let's see. Now in place of momentum or P, I am writing mass into velocity. So I have written it. Again, I took the mass outside and then written this del V by del T, where mass is constant. Now what is del? Del here refers to change. Anything. Suppose there is a change. Initial velocity may be 0. First it was 0 when a stone is at rest. Again, when I applied a force, what happened? The stone became rolling and the speed was 2 meter per second. So what happened? There is a change in velocity, and that change is equal to, change in velocity will be 2 minus 0, that is 2 meter per second. So whenever there is a change, and this change is represented by del, and the symbol is given here del. Similarly, change in time, final time may be something, initial time may be something. So rate of change of momentum, wherever I use the word change, we will put a del symbol, which is represented by a triangle. So according to this definition, force is directly proportional to the rate of change of momentum, and that we have just elaborated it. Now I have kept mass constant. Why? Because mass is the quantity of matter a body contains. Right? Suppose a 5 kg of cotton is placed on earth, it will remain 5 kg. And if you take the 5 kg of cotton into the moon also, the same 5 kg mass will remain constant. So mass is constant, and so there is a change in velocity. Change in velocity by time. That is, velocity by time is equal to acceleration. So force is directly proportional to mass into acceleration. Mass is constant up to when the velocity is very less than this c. What is c? C is the speed of light. 3 into 10 to the power 8 meter per second. So when velocity is very small than the speed of light, then mass is constant. So now we get this formula: force is directly proportional to mass into acceleration. Now it's directly proportional, it's not equal. So for making it equal, we have to add a constant here, and that constant is k. Now if k is equal to 1, then what will happen? Force is equal to mass into acceleration. So we get this formula: force is equal to mass into acceleration, from Newton's second law. So this is a fundamental law. Now suppose, let's say mass of an object is constant. Suppose, let's say mass is 1 kg. So what will happen? If force increases, acceleration will increase, keeping the mass constant. Similarly, if acceleration is kept constant, then with the increase of force, mass will increase. Now let's see these graphs to understand better. Now first case was mass is constant. Suppose mass is kept as 1 kg. Let's plot this graph. You must have known this in maths. I am plotting this graph as 1, 2, 3, 4, 5, 6, 7, 8. Similarly here, 1, 2, 3, 4, 5, 6, 7, 8, like that. It goes on. So force is at 1 Newton. Then what will happen if mass is 1? Suppose force is at 1, mass is 1, then acceleration will be also at 1. So 1, 1, and they both match at this point. Similarly here they match. When force is 2, mass is 1, then acceleration will also be 2. So similarly we get this graph as this line. Similarly, the second case, keeping acceleration constant, we get, while plotting force and mass, we get this graph. Now in the third case, let's see this one. Here, acceleration versus mass, keeping force constant, right? Suppose force here is 100 Newton, let's say, right? When here, let's plot the graph so it would be easy for you to understand. So when mass is equal to 1 kg, what will happen? Mass is 1 kg. What will be the acceleration? Acceleration will be 100 by 1. That is 100 meter per second square. So when it is at 1, acceleration will be at 100. So as mass increases, acceleration will decrease. So this is how the graph is plotted. Now I have already told you that mass remains constant. But now we will see how change in momentum due to change in mass affects. Now we have learnt that force is equal to change in momentum by time. That is change in mass velocity by time. Now when velocity is constant, then change in mass by time. Where is this possible? Change in mass. I told you that mass remains constant even if you take the mass to the moon. So where mass is changed. Now first thing, remember LPG gas cylinder that is delivered to your home. First, the cylinder being full weighs suppose 11.5 kg or 12 kg. Then afterwards, when the fuel or the gas gets used up, the weight decreases or the mass decreases. then you can weight it and it will be 2 kg. So similar case happens in rockets or in airplanes where the fuel gets used up and so the mass decreases. So how this change in mass affects change in momentum? Let's see. So when mass decreases or when the fuel gets spent, as in case of rocket, so momentum depends upon mass and velocity. If velocity is constant, what will happen to mass? Let's see this example. Suppose I don't know the momentum. Mass is decreased. Mass was suppose 30 and velocity is, let's say it's 1 meter per second. So what will be the momentum? It was 30. Now if I decrease the mass is now 10. Velocity remaining constant. What will happen? This momentum also decreases. So as mass decreases, momentum decreases. So what will happen to the rate of change of momentum? It also decreases with decrease in mass. So there is a change in momentum. The rate of change of momentum also decreases due to change in mass. Let's see this example. What I have told you, that there is an upward force which is greater and the downward force by the fuel is less, so that the space shuttle takes up. But according to the conservation of momentum or force or energy can neither be created nor be destroyed. So in the first case, what happened? Mass or the mass of rocket, the rocket weight or mass cannot be changed. So mass remaining constant, the velocity, first it was moving with certain speed and then it picks up the speed. So there was a change in velocity in first case. So the momentum here is varies with the change in velocity. In the second case, the velocity remains constant, or the fuel case, the velocity remains constant and there is a change in mass. So there is a change in momentum due to change in mass, and this particularly happens in the case of where fuel is being used in airplane, in rockets. Now let's see what is impulse. We all know that Newton's second law says that force is equal to change in momentum by rate of change of momentum. By time we can say rate of change of momentum. So if I bring this del t to this side, what will happen? Force into del t is equal to change in momentum, right? And this one, this product, if mass is constant, then what I can write? Mass del v means initial final velocity minus initial velocity. So this product, force into change in time, is what is known as impulse. Impulse is the product of force into the duration of time or the change in time as written here. So let me tell you, you may ask what is impulse unit. So let's see what can be the unit of impulse. Force unit is Newton. So directly writing Newton into time. Into time is measured in second. So this is the unit of impulse in SI unit. Now will it be a vector quantity or a scalar quantity? Since force is a vector quantity, this impulse is also a vector quantity. Now let's see this example. Now as you can see, as soon as the person jumps into the plank, wooden plank, the boat moves away in the opposite direction. What happens here? There is an action force which makes the boat move away, and there is a reaction force. This gives us the Newton's third law, which states to every action there is always an equal and opposite reaction. But one thing that should be noted here is that both action and reaction always acts on different body. Though they are equal and opposite forces, and have same magnitude, but they always act on different bodies. So important point here is that Newton's second law is the fundamental law. Why? Because it gives us the formula of force, which is mass into acceleration. The first and third law can be obtained from the second law. So these are the three laws of Newton. First law was the law of inertia. That was the case for balanced forces. Then the second law, or the fundamental law, was based on unbalanced forces. Remember, the rocket, the force going upward is higher than the force downward. So there is an unbalanced force. This Newton's third law is about equal and opposite forces. So these are the three laws, and hope you have understood. If you have understood well, please like my video and subscribe to my channel for more videos. Thank you for watching this video.